Yes, we're continuing with chapter 6. Let's continue the discussion. All right, and before I start, I told you yesterday you need to memorize the name of these 4 most important quantum numbers, which are called principal quantum number. Right? We have another name for it. What's the other name? Do you know it? Hello? معايا يا شباب?
Energy level.
Yeah, it is called shell quantum number also. Shell quantum number. And it represents energy level. Okay. Now, the second one, what's the name of the other one? Angular momentum quantum number. Okay, what's the letter that we use for it? L. What's the other name for it? You have to memorize the other name as well. What is it called? Read it.
Subshell.
Subshell. Subshell. What's the third quantum number? Magnetic quantum number. Magnetic quantum number. What's the other name that we're going to use always for it? What's the other name?
Orbitals.
Orbitals. We're going to use orbitals. And we mean by that magnetic, we're doing it for magnetic quantum numbers. And then we have a fourth quantum number, which is called spin quantum number. Spin quantum number, which is MS. MS. Okay, you have to memorize the names extremely well, and even the sub-name like shell quantum number, subshell quantum number, orbital, and this is called just spin quantum number, electron spin quantum number. Of course, the shell represents the energy level. Yes, I agree with that, but I want you to know the names for these things. Okay, now we already discussed principal quantum number. Who developed the principal quantum number? Who developed the principal quantum number?
Bohr.
Bohr. What did he say? That the nucleus, the electron in hydrogen, we're talking about hydrogen atom. This is the nucleus, and around it there are what? Or circles, orbit, not orbitals, but orbit. And
Doctor, we can't hear you.
n equal to 2, n equal to 3. And the electron can jump from what?
One level to another level.
From one level to the other level without going in the middle, just like going upstairs. And it can jump from here to here, and to 4, to 5, to 6, to 7, to 8, to whatever. And so he developed the principal quantum number. Or what's the other name for it?
Shell quantum number.
Shell. What's the value that Bohr gave for n? Value. N value.
Any integer.
Any integer. Starts from what? 1,
1,
2, 3, 4, 5, 6, 7. Where should you stop?
Infinity.
Anything, any number, any integer. It must. So we know the value for n. The value for n is from 1 to infinity, 1, 2, 3, 4, 5, 6. So the value is clear. All right, clear? Good. Next, after Bohr came de Broglie. And he came up with a very important equation. What's the equation?
Lambda equal h over mu.
Mu represent what?
The momentum.
Moment.
M represent what?
Mass.
This means it's a particle, and mu is momentum, exactly. This means it's a particle, but lambda or lambda represent what?
The wavelength.
Wavelength. Okay, this means you can change particle into waves, or you can change waves into particle. This is clear by this equation. So if I know if you are moving at a certain speed, let's say you are 20 kilos and you're moving at a speed of 20 meters or 20 kilometers per hour, then I can tell what's your wavelength. Is this clear?
Yes.
What does that mean? We can change mass into waves, and we can change waves into mass. What's this called?
De Broglie equation.
Yeah, but what's the name of changing wave to mass or mass to wave?
Dual.
Dual function.
Dual function, changing mass to wave or wave to mass. Is this clear? Is this easy? Very good. After de Broglie came another scientist, which is and developed the uncertainty principle. What's the uncertainty principle?
Delta x times delta m, delta b.
M delta U, yes, or delta P, yes.
Greater than or equal h over 4 pi.
What's the name of this equation? It's this uncertainty principle. Who developed it?
Heisenberg.
Heisenberg uncertainty principle. After Heisenberg came another scientist, and he said he developed this letter. What's this letter?
Psi.
Psi. Who developed it?
Schrödinger.
Schrödinger developed this psi. And what's psi? What's psi?
Wave function.
Wave function. What do I mean by wave function? This means if the electron is a wave, then psi is the mathematical equation that represents the wave. That's the meaning of wave function. We said here the electron could be what? Wave. If the electron is wave, then psi is the wave function, the mathematical equation to represent this wave. What do I mean? If you have another wave like this one, as we said last time, then what's the equation? What's the wave function for this wave? For this wave?
Y equals sine x.
This is
Sine x.
sine x. This is called the wave function for this wave. The wave function for this wave. What's sine?
The wave function.
For what?
For electrons.
For the electron. Exactly. Is this clear? Very important. Now, even more important than psi is what?
Psi square.
Psi square. What does it Psi squared do?
The probability of finding electrons.
Probability of finding electron, or density of electrons. Density and probability of finding the certain density of electron intensity. Good. Is this clear so far? Okay, now we are going to solve the wave function. We're not going to solve it, we'll just apply it. Now, let's go back to y equal to sine x. If x is 0, then what's the value of y?
0.
0. If x is 90, then what's the value of y?
1.
1. Yes, you are giving solutions. Good. If x is 45,
1 over the root of 2.
1 over
Root of 2.
Root 2.
y is equal to 1 over root 2. See, these are solutions for the wave equation. Now we are going to solve the same thing with psi. But now we're just going to give you numbers. Now, I hope all of what I wrote here is important, but keep them in mind, but I'm going to take them away. Now, again, what's the other name for the principal quantum number?
Shell.
Shell.
What's the other name for angular momentum quantum number?
Subshell.
Subshell. Subshell.
Shell. Good. What's the other name for magnetic quantum number?
Orbital.
Orbital.
And then spin quantum number, keep it, no need. Good. Now, when we are solving for n, we're solving the wave equation, we're solving psi now. Okay? When we look for n, we found that there are two questions to answer. How many L? And the other question is, what are the value of L? You have to answer two questions for n. When you have any n, then ask how many L and what are the values for L. We found that whatever is the value of n, if I ask you how many L are there, you should answer, the answer is what? N. Okay? Now, what are the values? It will start from 0 and go all the way until you reach n minus 1. These are the values. Let's apply it and you'll understand it right away. If n is equal to 4, then how many L? How many?
4.
Yes, you should say right away 4. And now I'll ask you, what are the values?
0.
0,
1.
1,
2.
2,
And 3.
and 3. And see, we stop at n minus 1, which is 4 minus 1. But count them. How many solutions? How many?
4 solutions.
4 solutions. Good. Let's change this. I'll take all of this away. And let's do it for something else. Let's say that n is equal only to 2. Then how many solutions?
2.
2. Always keep this in mind. Okay. What are the solutions?
0 and 1.
0 and 1. The last digit is equal to what?
N minus 1.
I hope this is clear for everybody. Good. Good. Now, let's take this away again. I'll give you more difficult one. Let's say that we have 6. Then how many solutions do we have?
6.
6. How many? Always same number. 6. What are the values? Or before we do this, when we have these 6 values, what will be the last value?
5.
5.
What are the values? Okay, let's count them. 1, 3, and we'll stop at 5. Count them. 1, 2, 3, 4, 5, and 6 solutions. Is this clear? Good. I hope this is clear and you are able to do it. Now, I'll do something else. I'll change this one more time and last time, and then we'll go to something else, but let's have it only at 3 at this time. N equal to 3, then how many ml? 3. What are the values?
3.
What are the values?
0, 1, and 2.
Now, I'll give you something else. For L, when the value is 0, or 1, or 2, or 3, we have another name for it. We don't have to say 0, we can say it is S. And for 1, we're going to call it P. And for 2, we're going to call it D. And for 3, we're going to call it F. Clear? So I want you to change the names here. Instead of 0, 1, 2, give me the other names.
SPD.
SPD. Good. Is this clear? So if we have 3, we have 3 solutions, SPD. How about if we have only 2? Of course, when I say I have only 2, how many solutions?
2 solutions.
2 solutions. What are these solutions?
S and B.
Only. Fantastic. All right. And last thing, how about if I have N is 4, then how many solutions do I have?
4 solutions.
4. What are the values? Or what's the name, not value?
S. SPDF.
DF.
Clear? Clear? What's the, okay, instead of SPDF, let's have also the number. What's the number for 0? For S?
0.
What's P?
1.
0.
For
1.
P, 1. For D?
D2.
2.
2.
For F?
F3.
3.
Keep this in mind all the time. Now, we usually write the principal quantum number in front like this, and then we write the L quantum number like this. Then, if I have 7d orbital, what's the principal quantum number for this orbital? What's N?
7.
7. What's L?
2.
Yes, L is 2 because it's D. This means it's 2. Clear? We already know these 2 quantum numbers. Let me give you something else. Let's assume I have 8 S. What's the value of N?
8.
8.
8.
Okay, what's the value of L?
0.
0.
0. Without thinking. 0. Is this clear?
Yes.
Very good. Done with the L, and I hope this is clear and you can solve it. Now, let's go to something else. I'm going to take all of these again. I will write here shell subshell, and then orbitals. I want you to memorize these names very well. Now, if we have L, then I have two questions. How many ml in it? And the other question, what are the value? Okay, and if you have L, whatever L is, if I ask you how many ml, you should say the answer is 2L plus 1. If I ask you how many, you should say 2L plus 1. And then, you put the value for L, whether it's 0 or 1 or 2 or 3 or whatever. Now, if what's the value? The value that you're going to give started from minus L, and you go to 0, and then you go to plus L, all the way to plus L. Let me give you an example, and things will be clear. Let's assume that L is equal to 2. Then my question is, how many ml?
5.
Yes, thank you.
5.
5. How did you find it?
2 multiplied by 2 plus 1.
Exactly. What are the values?
Minus 2. Minus 1.
Minus 1.
0.
0.
1.
Minus,
And
minus 2. Oh, sorry. Plus 1 plus 2. Yes. Count them. How many do you have?
5.
So this is the answer. 5, and the names start from minus 2 to minus 1. Is this easy? Is this easy?
Easy.
Good. If L is equal to P, then how many ml?
2B plus 1.
Yeah, give me numbers.
3.
Yes, the answer is 3. Why did you say 3?
B is 1.
P is
P
1.
is 1. Exactly. And that's why 2 times 1 plus 1 is 3. Exactly. What are the solution?
minus 2. Minus 1.
minus 1, 0, 1.
Yes, minus 1, 0, and plus 1.
0.
How many solutions?
3.
3 solutions. That's what we said here. And the solution is minus 1, 0, and plus 1. Is this clear? Clear?
Yes.
Good. I hope so. Good. Now, when L equal to F, let's do it here, no problem. When L equal to F, then how many ml? How many?
7.
7.
Exactly. What are the values?
From minus 3 to 3.
Minus 3, minus 2, minus 1, 0, 1, 2, and 3. Count them. How many are these numbers?
7.
values.
7.
Which is this number? Can you do that? Is it easy?
Yes.
We will
Yes.
make each orbital as a box. And sometimes we just put the line like this, but we'll do it as a box now. Okay? Which atom we are dealing with so far? All of this work is with which atom?
Hydrogen.
Hydrogen.
Hydrogen atom only. Hydrogen atom only, and we are solving the shape of the orbitals. All right? We'll make box to represent the orbital. So how many boxes should I put here? How many? 5.
5.
Always, always, when we have S, how many boxes we are going to have?
1.
Only 1. Why? Because in this case, L is equal to 0. And how many? You will say it's 1. And what's the value? What's the value?
0.
Excellent. Is this clear? Now, when we have P, what's the value of L? What's the value for L?
1.
1. How many ml?
3.
3 orbitals.
3.
I will draw them as 3 orbitals, 3 boxes, 1, 2, and 3. What are the values?
-1, 0, 1.
-1, 0, and 1. When L equal to D, what's the value for L?
2.
2. How many ml we have?
5.
5.
5. So I'm going to draw how many boxes?
5.
And what will be the values?
-2, -1, 0, 1, and 2.
The order is not important, all right? And last one, if we have F, how many orbitals we have?
7.
7.
Then don't forget this. What are the values?
-3, 3.
-3, +3, -2, +2, 1, -1, and 0. Is this acceptable?
Yes.
Acceptable, no problem. Is this clear?
Doctor,
Yes.
what do these values represent?
Just mathematical equation. What's the meaning of 4 when you, what's the square root of 16?
Plus 4.
4. What's the meaning of 4?
1 solution.
No, it's a number only. Number.
Yes, but it is a solution for.
Yeah, I know, but it's a mathematical number. It has no physical meaning. Yani it's a number.
Okay, I got it.
The same thing with here. These are just numbers to represent the solution of equation. They have no meaning. Yani, if you tell me what's the difference between -3 and +3, I will tell you there's no difference. It's just numbers to represent the orbital. Is this clear?
Yes, it is.
Good. Now we are still with the hydrogen atom, and we have all these solutions. Don't forget this solution. Let's go to this drawing now. When n is equal to 1, how many L do we have?
1.
I will write these things one more time. N, always I'll ask you how many L? What are the L's? What are the L? Okay, and the other question, if we have L, we'll ask you how many ml, and the other question is, by the way, for how many ml, always that's, I'll put it the other way, no, not this way, I'll put it the other way. Always keep in mind that when L, that's the other one, L is S or P or D or F, then you should answer always. When we have S, how many ml do we have? How many ml?
1.
one orbital,
1,
which is one box. Okay, when we have P,
3,
3,
3,
when we have D,
5,
5. Keep this in mind. And when we have F, we have 7. Clear? Good. Next, if we have n equal to 1, how many ml? How many L? N equal to 1. How many L?
1,
3.
1,
Answer is N. Don't forget this. Okay. What's the value for this one?
0,
What's the other name for 0?
S,
So if we have N1,
S,
how many orbitals we have? Only one S. Clear? Clear? I hope so. If n equal to 2, n equal to 2, how many L we have?
2.
2,
have 2,
What are the values?
0 and 1,
0 and 1, but we don't want 0 and 1. We want the other name, which is?
S and
Yes,
P.
and P.
So you find that in n equal to 2, there is two solutions, N and P. Clear? When n equal to 3, how many, n equal to 3 now, how many solutions do you have? For
3,
3,
3. What are the values? From
0,
to n minus 1, which is what?
S, P, D.
Which is SP and D only. Okay, and that's why when n equal to 3, we have S, P, and D only. And these are the number of orbitals in each one of them. When n equal to 4, how many solutions do we have? Same number.
4,
4. What
4,
are the values? 0, 1, 2, and 3. And what's the other name? S, P, D, and F.
B, D, F.
All of this is for the hydrogen atom. All right. Is this clear so far?
yes,
Yes, yes.
Good.
Yes.
Next, I'm going to do also in here. Yes. Here. Now, I will put them another way of doing things. When n equal to 1, n equal to 1, how many ml we have?
Three.
How many ml? How many L? How
1,
many
L1, yeah.
L? Always the answer is n. Okay, and what is the value? You have to keep this in mind all the time. It's from 0 to n minus 1. Okay, so when n equal to 1, how many L are there?
1,
1. What's the value?
0,
0. And that's why if you
0.
look at the box here, there is only one L with 0 because n is equal to 1. What's the value of ml? 0.
also 0.
Also 0. Is this clear? Okay. When n equal to 2, n equal to 2, all right? How many L do we have?
2,
2.
2.
What are the values?
0,
0 and 1,
0 and 1. What's the other name for 0 and 1?
S and P.
S,
E and F. Okay, so this one will be, so we're going to call this orbital as 2s, and this orbital we're going to call it 2p. And this orbital, of course, what are you going to call this orbital? What's the name for this orbital? First one.
1s.
1s.
This one.
Okay, clear? Okay. When n equal to 3, how many L are there?
3.
3, always. Keep this in mind. N equal to 3, this means n equal to 3 also. I mean 3, what are the values?
0 and 1 and 2.
1 and 2, these are the 3 values. What's the other name?
SPD.
And that's why I'm going to call this orbital as what? 3 what?
3s.
S.
This one 3p. This one
3D.
is this clear? What's the value of ms in 3s?
One.
The value for
as I
what?
said, whenever you have this orbital for ms, ml, ml. What's the value for ml? Always, when it's s, what is the value?
0.
0.
What about p?
-1, 0, 1.
Exactly. How about d?
-2, -1, 0, 1, and 2.
Exactly. How about f?
-3, -2, -1, 0, 1, 2, and 3.
Clear? I hope so. Now, we're done with this one. We have the names. Now let's go to this one. N equal to 4. How many solutions?
4.
What are the solutions? 0, 1, 2, and
3.
3. What's the other name?
F.
SPDF.
Okay, what's the name of this orbital?
4s.
4s.
S. What's the name of this orbital?
4p.
4p. What's the name of this orbital?
4d.
4d. And the last one?
4f.
Okay. Now, if I have electron in here, okay, what is the value for n for this electron? I have electron like this. What's the value for n for this electron?
4.
4, n equal to 4. How about L?
F.
F, or what's the number?
3.
3.
3. Good. How about ML?
-1.
-1. Good. Excellent. Is this clear? Good. I'll put another electron and put it here. What's the value for this electron? What's the value for N?
4.
Again, 4. It is in 4. Okay. What's the value of L?
1.
1.
1.
Fantastic. Why are you saying 1?
اسم subshell
S
P.
because it's an S.
P. P means 1. Is this clear? Okay. What's the value of ML?
0.
0.
0.
And so we can tell what's the 3 different quantum numbers for any orbital. Clear? Let me give you another example. Let's say I have electron in here. I'll put electron here, and I'll say this one is 7p. Then what's the value of for n for this electron?
7. 7.
7.
7. From where you get it?
The 7.
First number 7.
Yeah.
Number before the letter.
1.
1.
1. Fantastic. From where did you get it?
P equals
D.
2.
P.
He is 1. Exactly. What's the value of MS? ML?
Maybe -1 or 0 or 1.
Exactly. Yes. Fantastic. And fantastic.
She thinks that I should put myself out there.
What? What? It could be 0. If you say 0, it's correct. Right. But is there any other answer? Yes, I can. Somebody else
Minus
can.
1 or 1.
Minus 1 rule.
But should not only one number. So I can say -1. Is this correct? It is correct. How about if I say no, I don't want it, or I don't want it -1, I want it +1. Is it possible? Yes, possible. I hope this is clear. So we can tell the 3 quantum numbers for the electron. Now, last quantum number that we're going to talk about is spin quantum number. Spin quantum number. Okay, spin quantum number has nothing to do with last one is spin quantum number. Spin quantum number, which is MS. If I ask you how many solutions, you should say what? 2 only, always, regardless of anything. If I ask you what is the value, you should say +half or -half. And when we draw the arrow like this means probably +half. And we draw an arrow like this. What does that arrow means? -half. Okay, let's go back to our orbital and let's put an electron here like this. And then I will say that this is
Hello.
الدكتور فصل عليه.
فصل على الدكتور.
إيه، الظاهر فصل عنه.
أول ما فصل عليه طلع صوت التيمز.
تمام.
السلام عليكم.
عليكم السلام
عليكم
ورحمة
السلام ورحمة الله.
انقطع الخط ما ادري شو المشكله، كان عندي عليه حل. الان فتحت التحضير. اوكي، لو تقدرون تدخلون على التحضير تسوونه، بس ابغى اتكلم اشرح شيء بسيط. ما ادري ايش كانت المشكله في البرزنتيشن. فخلني اوكي. اخر شيء تكلمت عنه كان MS. التحضير مفتوح، بتكلم عن MS شويه وبنوقف وتقدرون تسوون التحضير اللي عنده شغل ولا شيء يقدر يطلع. بس I just want to say that if I have an electron like this and it is 8d, then what's the value of n?
8
8.
8. Fantastic. From where you get it?
from the number.
Good. What's the value of L?
2.
2
2. Why?
because D equal to
D. Very good. What's the value for ML?
minus 2 0
Minus 2, 2, 0, 1, and minus 1.
Yes.
Which one should I take? Anyone. No.
Anyone.
Okay, give me one.
minus 2.
Minus 2. Fine. I don't mind. Good. Last question is, what's the value of MS?
What's the half?
Yes.
Plus half.
Plus half. Now, we agree that this is plus half and this is minus half. But also, if I say, no, I don't want this, I want to reverse it. I will put this is plus half and this is minus half. Is this acceptable? Yes, it is acceptable. But let's always, almost always agree that that is the plus half and this is minus half. Clear? Very good. And now you should be able to write the 4 quantum numbers for each one represent electron now. And now if I will give you another example very quickly. Let's say we have another electron like this, and let's have it as 9s. Then what's the value of n?
9.
9. What's the value of L?
0.
0
0.
0. Why?
S.
plus S.
Okay. What's the value of ML?
0.
0.
Do we have any other choice?
No.
No.
No, only 0. Only 0, because it's one orbital. All right. And then when I say MS, what's MS?
minus half.
So I can tell what are the 4 quantum numbers for this electron. Don't forget that the S, how many orbitals does it have?
1 orbit.
1.
It's always 0. 0, the value. For the P,
3.
3 orbit.
what are the values?
Minus 1, 0.
minus 1 0 1.
And D,
5 orbits.
minus, I can say minus 1, plus 1, 0, minus 2, plus 2. No problem. Okay, clear? Okay, good. And last one is F.
7 orbit.
What are the values? Minus 3, minus 2, 0, minus 1, plus 1, 3, 2. It doesn't matter. As I said, you can put any numbers. Keep all these values in your mind. In the next lecture, I will give you just electron in the atom, and I'll tell you, give me the value for N, L, ML, and MS. Is this clear?
Clear, doctor.
I wish you all the best. Then, inshallah, I'll say, Masa, the lecture is over, and you can leave.
دكتور
Yes.